For this experiment, gloves and goggles are mandatory. Also, glacial acetic acid can cause chemical burns, so be careful. The iodine clock reaction is where two colorless solutions are mixed, and after a certain period of time, a sudden color change occurs. There are many variations, but in this video I will be presenting the potassium iodide hydrogen peroxide variant. For this experiment, we'll need to create two solutions. Solution A contains 50 grams of potassium iodide, 4.1 grams of anhydrous sodium acetate, 9.4 grams of sodium thiosulfate pentahydrate, 0.6 grams of soluble starch, and 1 liter of water. Solution B is much easier to make and only contains 500 milliliters of 3% hydrogen peroxide, 30 milliliters of glacial acetic acid, and an additional 470 milliliters of water. I will first make solution A. Next, add 0.6 grams of starch to an empty container, followed by several drops of cold water to wet all the starch. Pour 100 milliliters of boiling water onto the wetted starch. Stir the solution until it becomes completely clear. Cloudiness indicates undissolved starch. Keep stirring and keep it on heat until the solution becomes completely clear. Once the solution is cleared up, you can remove it from heat. Pour the starch solution into a suitably large container labeled A. To the starch solution, add 500 milliliters of water. Next, add 9.4 grams of sodium thiosulfate, followed by 4.1 grams of sodium acetate, and then 50 grams of potassium iodide as the last ingredient. Once all the ingredients have dissolved, top this off with 400 milliliters of water. At this point, you have finished making solution A. Solution B is much easier and quicker to make. And now we'll make solution B. To another container labeled B, add 500 milliliters of 3% hydrogen peroxide. Next, add 30 milliliters of glacial acetic acid. And finally, top this off with 470 milliliters of water. Mix the solution thoroughly, and solution B is now complete. These are my final ready solutions. In this video, solution A seems to be a little bit cloudy. It might appear this way if not all the ingredients completely dissolve. If your solution is a little cloudy, just let it sit for several minutes and it should clear up. Now to test it, mix equal volumes of solution A and solution B and mix them together thoroughly. It's called a clock reaction because it takes a very predictable amount of time for the color change to occur. The time that it takes for the solution to change color can be altered and controlled by changing the amount of sodium thiosulfate that is used. And in several seconds, the solution should change to its dark blue-black color. Here, I wanted to see what would happen if I made an effort to mix the two solutions together as little as possible. At this point, I'm going to explain chemically what's going on. This experiment actually involves 4 different reactions. I'll start with the second one, which is the slowest, and because of this, it is the rate determining step. Aqueous iodide molecules react with hydrogen peroxide to form iodine. As soon as the iodine is formed, it reacts with the thiosulfate ions to regenerate the iodide ion. This is represented by the third equation. The conversion of iodine back to iodide is so fast that it effectively keeps the concentration of iodine around 0. This back and forth conversion between iodine and iodide occurs until the thiosulfate ions are exhausted. At this point, iodine can't be reduced back to iodide and it will start to build up. Now referring to the first equation, iodine will react with iodide to form triiodide. The triiodide then reacts with starch to create the starch pentaiodide complex, which has a characteristic blue-black color. You can see that by changing the amount of sodium thiosulfate that we use, we can change how long the iodine bounces back and forth with the iodide, and therefore we can control how long it takes for the color to change. I then halved the concentrations by adding 50 milliliters of solution A followed by 50 milliliters of water, and then doing the same for B. So now both solutions are at half the concentration that they originally were. This time, it takes about twice as long for the color change to occur. It takes about 50 seconds instead of about 25 seconds. I'm not going to fast forward this, so feel free to skip ahead. One funny idea might be to mess with people by carrying out the reaction in a water bottle and pretending that it's water. I think it has a pretty good potential to cause some confusion.